warm welcome to this session, the business uses of analytics. My name is Patrick Quel. I'll introduce myself more thoroughly in a minute, and together with my fellow panelists, I would just like to encourage everyone to use the hashtag data echo culture, if you'd be so willing. If you want to speak on social media about this, we have live translation, which should be available by clicking on the FREN buttons at the bottom of your screen. Another piece of housekeeping is that I'm reminded to ask you that we are recording, and so therefore if you don't wish your image to appear, then please you can turn your camera off. What we will be doing is sharing some of our experiences from the use of artificial intelligence in various different settings that are mainly outside the cultural sphere, and then relating it back to how those kinds of technologies can be used in culture. And we've deliberately kept the talks quite short because we want to ask each other questions, because the preparatory sessions that we've had for this have always been too short, because all the case studies seem very interesting to me. I hope they seem as equally interesting to you. And so that's a little bit of a panel discussion, but also we're very, very willing to take questions from the floor. And so if you would like to put questions into the chat, that would be fantastic. And I will endeavour to parlay them into us discussing them in the group. So I think we've probably got everyone who's going to be here now. So my name is Patrick Quel. I'm the Innovation Director of the Audience Agency, which is one of the partners in this event, alongside dear colleagues at Sign Up Seek. And everyone wonders what my job is, and I wonder what my job is as well. It's to do fun, interesting, new stuff. And I think there's nothing more fun, interesting and new than artificial intelligence, although some people might argue about the new. I do remember studying it when I was at university in Cambridge. I did some multi-agent reasoning systems and things like that sounded very clever at the time, back in the early 90s. But it's fair to say that it's probably taken the majority of our professional careers for these things to come through, to be in devices like this and apps and other systems that are within the reach of small to medium enterprises, which is what most cultural organizations are. And so I think other than to welcome you and introduce myself, it's now for me to introduce or ask Phil to introduce himself. So would you like to proceed, Phil?
Absolutely. Thank you, Patrick. Good morning, bon matin à tous. Good afternoon, good evening to all those elsewhere in other parts of the world. So my name is Phil Mitsopoulos. I'm an account director of customer success at a Montreal-based company called Strategy AI. I've been there close to 5 years, which feels like an eternity in the AI space. Things move so fast, but I've been on the job market for about 20 years. Prior to joining Strategy AI, I worked at two of Canada's largest telecom providers, Bell and Telus. So, I went from basically a large enterprise, well-structured, to a small startup where, you got to wear many hats to survive. You learn a bunch of things on the fly, and also learning about a new technology, AI. I don't know how to code to this day, but, I've over time kind of gotten a pretty good grasp and understanding of the power of AI, how it works. And in my day-to-day role, I help customers essentially gain business value through AI by using a platform that Strategy AI has developed called Quel. It's an AI business platform. Essentially, it allows non-technical business users to harness the power of AI without knowing any code. So I help clients kind of guide them through the process, identify different use cases, and then through our platform, use different workflows to achieve specific outcomes and gain value, get insights, make predictions using AI. So I'm going to provide a few examples of that a little bit later, but pleased to be on this panel. And I guess I'll shift things over to Mark for his introduction.
Hey, thanks very much, Phil. And good morning, good afternoon, good evening to everybody. My name is Mark Langley. I'm the Chief Technology Officer at Magnify Digital, which is a Vancouver-based agency. I lead the development of their viewer-centric product, which is a tool for looking at audience analytics and pulling data together into a single platform for that. Prior to jumping into Magnify earlier this year, I was in the aerospace industry for 30 years. I'm an aerospace engineer by training. And my first exposure to AI was in 1991, when as my final university project, I tried to develop an autopilot powered by a neural network. That failed pretty miserably, but like a machine learning system, I improved with time. And 10 years later, I'd become the technical co-founder at a company that uses AI to improve the quality of maintenance in the aviation, automotive, and heavy industries. I've also authored 5 patents in that area. The software that we developed in that role drives reliability at companies like Bombardier, Pratt & Whitney, Lockheed Martin, Gulfstream, Aston Martin, and the list continues on. It's used on 1/4 of the world's airline fleet, including some of North America's biggest airlines. So if you've ever flown commercially in the last few years, maybe not so much the last 12 months, there's a good chance that we contributed to your safe and timely arrival. But if you took a maintenance delay, 75% of those planes weren't using my software. So that was probably my competitor. I believe AI has already accomplished many impressive achievements, but it's not a silver bullet. And I do think it's important for organizations exploring AI projects to go into it with their eyes open. There's lots of ways that you can trip up, and some of those transcend technical issues and go into areas of ethics, equity, and fairness. While that won't be part of the presentation today, it is something I'm happy to chat about in later discussions. Just to wrap up the introduction, I'll say that when I met my now coworkers at Magnify Digital, I was really struck by how readily the technologies that we had used transfer to the cultural industries. And I'm really excited by the opportunity to share the insights and help avoid some of the common mistakes that other industries have discovered along the way. So thanks. Back to you, Patrick.
Goodness. So I think that one of the things that we should do is make sure that we're covering off with particular words that are technology words, kind of so that we don't have too many technical terms. And so this is a kind of game of buzzword bingo that you can play in the chat if you want. So if we say a word and you don't know what it means, you put it in the chat, and I will not immediately, but at the end of a paragraph, pause us and make sure that we define it. So far, I think we've kind of introduced the idea of artificial intelligence, and I think we're broadly meaning that to be any kind of computing method that kind of replicate how clever us humans are. We're assuming that we're still on the top of the evolutionary tree, which we might question. And then along the way, we will kind of pick out certain different kinds of artificial intelligence that can be applied. One of them already that appeared was neural networks, and those are kind of systems that replicate some of the neurophysiology in our brain. So they're literally having neurons that fire, well, not literally, but they're computing things so that it's as if there is a kind of network of neurons like in our brains. And I mentioned multi-agent systems earlier without defining them. So that's when you have multiple different kind of artificial intelligence computer things going along, trying to solve a really complex problem. You kind of have more than one doing it at the same time. I remember back at university, I did mine around people choosing which film to go to see, which is maybe why I've ended up working in culture. And so just wanted to go back to Phil and say, could you give us some of those case studies of what you've learned through your career? And then we'll kind of see what the read across is into arts and culture and heritage.
Yeah, absolutely. Thank you, Patrick. So I've got a few different use cases that I want to go into, and I'll try and draw some parallels into the cultural sector. I think actually one of my examples is taken straight from the cultural sector, but the first one I want to talk about is a demand forecasting use case. So essentially, I've been working with a watch manufacturer, largest in their country, to essentially forecast demand of their different watches. So we're talking about thousands of SKUs or different types of watches of all different shapes and sizes. And the issue they have is that they can never really accurately forecast demand and try and anticipate, how many watches they should order, when. Oftentimes they'll either order too many and then they'll have to liquidate all the excess watches, or they won't order enough and they'll sell out within days, and then they have to wait another 6 to 9 months to get more parts from Asia and then produce that model. So you've kind of missed the boat literally when it comes to that. So that was the use case, essentially forecasting demand, and from the get-go, I think the biggest issue, and this is probably the biggest issue, almost, all our customers, almost every organization that kind of goes into AI faces, it's the issue with data. You either don't have enough, or it's not structured well enough, or it's not clean, or you just simply don't have any. So in their case, they did have data, but not enough of it. And it also wasn't always well structured, and there was often mistakes in it. So the first kind of step that we had to achieve was essentially to ensure their data readiness. And that's always the longest part of it. It's not actually doing the AI. Our platform honestly kind of takes care of all that. It's really getting all your ducks in a row, getting your data ready. And if I had to break that down into three key actions, the first one is collecting the data. So whatever you have, their source data was in an SAP database that they use, that their factory kind of uses. So anytime they have an order kind of coming in, they'll input kind of different details related to the watch. And we're talking about over 100 different features. Like, it gets quite complex. I was shocked that there was these many little pieces of data just tied to a specific type of watch, like the color of the band, the length, the width, the color on the dial of the watch. Are there any numbers? Are they standard numbers? Are they Roman numeral numbers? It just goes on and on. So over 100 different characteristics for each type of watch. So we had to extract that from SAP. The next key action was what we call pre-processing the data. So that's kind of getting your data ready for the use of AI. So exploring the data, gaining a better understanding of it, standardizing the data format, like the different categories, different families for the watches. Then you have to clean the data, sometimes delete impossible data. You have to edit the data to clean mistakes, and sometimes just reduce the data. If you have certain characteristics that aren't relevant, it's just kind of getting rid of that. And then you transform the data. So that's kind of normalizing the data, standardizing things across different categories. Suppose you have measurements in centimeters and then in millimeters, maybe in inches. It's just putting them on the same scale for the AI to be able to really make sense of the numbers and put them on the same scale. Then kind of generating new features from the existing data. For example, if you have a launch date for a watch, you can extract from that launch date, what month it was launched, what year it was launched, what week number, what specific day it was launched on. And these may or may not be relevant depending on the use case, but that's like a classic example of how you can kind of generate new features or new types of data from existing data. So that was kind of the first big step, ensuring data readiness. And then we had our kind of data and then kind of running a few different workflows in our AI platform. And it's still a work in progress. You know, AI projects are often kind of never ending in the sense that you can always push the bar higher and higher. It's important to set up your goals from the onset and define what success looks like, right? Is it achieving maybe an 80% level of accuracy? Maybe, you know, if it's not above 95%, it's not good enough to take to production and make use of it. So it's very important to set up those expectations from the get-go. And kind of the parallel I can draw with that demand forecasting use case is in the cultural sector. Another customer of ours, in fact, Synapse, that's organizing this event, the Data Echo Culture event. One of the they've been using our platform, and one of the first use cases they were on was essentially to predict ticket sales for cultural events. So, you know, it's basically using the same type of workflow. It's called a regression workflow, where you're predicting a specific number. So instead of predicting how many watches you're going to sell during the first 12 months from the time that a watch launches, you're predicting ticket sales for a specific type of event. So that data was kind of pretty well structured. We got results pretty fast, achieved, I think for that one, like a 75% level of accuracy, which was not bad, considering, you know, very little time was spent on it. And some of the features that were kind of most relevant, as you could imagine, was the type of show that's being put on, the size of the venue, what time the event is happening at, as well as kind of what the weekday is, right? So this is all kind of makes sense, but you can definitely push the bar higher and achieve a higher level of accuracy by integrating, you know, new features like maybe who are the artists that are participating in that event? Maybe, you know, some more seasonality related metrics, maybe past ticket sales for similar type of events, and so on and so forth. So, you know, I think to summarize, you know, with AI, the business problems from one industry to the next will be different, but the techniques and methods are always the same. And that's where kind of we hope to help organizations accelerate their adoption of AI through our platform by having one that's non-technical. So really allows for non-technical users to harness the power of AI and gain insights, gain value very quickly. All they really need to do is essentially have a good use case, a good business problem to solve, set up kind of the, you know, what the success look like, and then our platform can handle the rest. So those were just a couple of examples on my side.
Brilliant. Thank you very much. And so I think one of the points that we've got over here is that the artificial intelligence is needing data. And obviously there are different kinds, and there's some that you train with data. There's others that they need that raw material. And so actually that getting the raw material together is a key part of the process. And even where in your case, you've actually done the clever stuff separately, but the big piece of work is after defining the problem is sorting out data. So I suppose I can always say more about data. In terms of the audience agency, one of the reasons why we're excited about it is because in a sense, in the UK, we've got one of the biggest cultural engagement data sets already in the world, and working with Synapse and across Canada, hopefully we'll end up with another very large data set. And that's the kind of data set that one can apply data to, as well as the data held by individual institutions. So brilliant, thank you. And Mark, you were going to give us some different examples from your experience.
Sure, happy to do so. So I'm going to talk about a couple of examples coming out of the industrial AI world that I used to live in. And the first is, fairly similar to Phil's project in terms of using machine learning to do some predictive work. The second is using a different, lesser known technology that I'll talk about, and it's actually looking at historical information in order to give guided instructions on what you should do next. So let's start off with the predictive project, and I'll just set the stage. What we're doing here is predicting failures in industrial assets that are very expensive to own and operate, and where downtime can actually kill you. And it can kill you financially with automotive assembly lines, where if the line stops moving, you're losing revenue at the rate of hundreds of thousands of dollars per hour. Or in the case of an aircraft, it could actually be literal death. So keeping these things up and running is very key. And there's a whole engineering sub-industry that's centered around asset management, reliability, and maintenance. And then within that industry, there's smaller communities that are coming at the problem from different approaches, one of which is predictive maintenance. And that's what I'll be talking about. Predictive maintenance tries to identify problems before they happen. Even when something breaks suddenly, there's usually clues that the failure is coming. And if you're careful and observant, you can pick up on those. A good example of that that's kind of classic in the industry is jet engines. They have temperature sensors installed, and if the temperature patterns start to shift, that's a really good indicator that one of your fuel injectors may be starting to wear out and inject too much or too little fuel. So how do you know that the temperature patterns are shifting? You've got sensors built into the engine and everything else, and aircraft are basically flying data factories, recording megabytes and gigabytes of information on every flight. And that data all feeds into predictive maintenance systems, which historically have been based on statistical analysis. And those are really good at catching all the low-hanging fruit. But the non-low-hanging fruit is still expensive enough and danger enough that it's worth going after as well. So that's what we tried to do, was we were trying to create a predictive diagnostic system that could identify a pending failure sooner than the existing systems could. But they were already checking all the obvious patterns, so how are you going to do better than that? And the answer that we turned to was really machine learning. It excels at taking vast quantities of data and letting you run it through algorithms to make predictions. And initially, the predictions tend to be gibberish, but as you show them more data and train them repeatedly, the algorithms adjust and they start to perform better. And eventually they get to the point where you can pick up subtle patterns that the human engineers don't even see. We, for example, were able to pick up correlations between activity in the electrical system and landing gear being slow to deploy that indicated a hydraulic pump problem. So two somewhat unrelated systems diagnosing a problem in the third one. So how can we apply this to the cultural industries? In my spare time, I'm a cyclist, not necessarily a great one, but I am an enthusiast. And let's pretend I've always wanted to film a cycling documentary. I've raised a few $100 from my friends and family. I feed it into a model that I've created. What's in this model? Well, this model could be driven by data that's coming out of IMDb. I could be going in there, getting a set of historical projects with their genre, their language, producer, director, top billed cast. What have those people worked on in the past? Who are the screenwriters? What's the budget overall and categorized? How many social media page followers do they have? Throw all that into a system and predict viewership by country, by region, by demographic. So let's pretend I've trained this system. I take my cycling documentary idea, I feed it in and I say, well, it's about cyclists and they're located in Southern Ontario and I've got $500 to spend. And the model churns and it comes back and it says, guess what? You're going to get 50 views. The demographic is going to be entirely in the sports and fitness area, and they're all going to be Southern Ontario. And I look at that, I think, well, so my ride club is going to watch my documentary, and that's no good. I want to do better than that. So now we do something magical with the model. The model lets me see how my predicted viewership changes as I change my inputs. So I can start playing some what if scenarios. Let's say rather than filming me on my bike, we hire Pedro Pascal. The model says, hey, if you put Pedro Pascal on this project, your viewership's going to go up. It's like, huh, okay, that's cool. That works for me. Then I look at what it costs to hire Pedro, and I think maybe not. What if I relocate production? Instead of boring Ontario back roads, I film it on scenic roads outside of Whistler. Okay, viewership goes up, that's good. And my costs went up too, but not as much as if I hired Pedro. So now I'm looking at booking some rooms in Whistler. Kind of a contrived example, and obviously I'm never going to get my cycling documentary filmed, but I think, you know, as you look at actual real world projects that you're working on, maybe you can see how this sort of approach can show ways that you can tweak a project in order to increase its viability and ensure better success in the marketplace with it, while also still hitting the cultural goals that you've set for it. So I'm really excited that using technology like this, we can empower creators to do that what if analysis and explore the options for their projects. I think it's particularly interesting and could really be a force enabler, particularly for projects that have a strong strong cultural goal, but have questionable commercial viability. And can we tweak them in a little way that increases the opportunities of success for those? Second project I want to talk about is one that I really like. It was the first commercially successful project that I did, and it also uses case-based reasoning, which is a lesser-known branch of AI. Machine learning tends to get all the attention these days, but there are other games in town. They're all algorithm-driven, and algorithms are like actors. They each have their own specialty, and because you excel in one area, it doesn't mean that you'll excel in another. Key to success in AI is really how much data you have versus how much you need. Machine learning wants lots of data. As you go along a spectrum, there are other approaches that require a lot less. So you can take a look at how much data you have and then decide which AI branch you want to follow. As we work across the spectrum from least data to most data, you start off with expert systems that require really no data, just a human expert who can describe in great detail how to make correct decisions. And you pick their brain and you codify their logic and then you run it. Next over is Bayesian Logic, which requires a lot of human knowledge, but starts to make use of data, mostly in a statistical way when it's available. Case-based reasoning, which is the one I'm going to talk about, kind of sits at that crossover point between the world of experts and the world of data. And then at the other end, you've got the machine learning where, you know, I can kind of stereotype the attitude as forget the experts, just give us all the data, we'll figure it out. So my case-based reasoning project, what case-based reasoning really excels at is pulling recommendations based on past similar experiences. It's really well suited to applications where you don't have a ton of data to draw upon, but you do have some human expertise that you can capture. And the tools that support it are really well set up for that. In the past, we used case-based reasoning to help technicians troubleshoot equipment failures. Basically, you could say, I've got this big, red, scary, blinking light on the control panel in my cockpit. And the software will say, hey, no problem. I know 37 different reasons why that light might have turned on. Let's figure out which one we're really dealing with. Then it goes off and it does its math and it figures out what questions to ask you in what order to narrow down the options, and gives you an intelligent interview that adapts on the fly to whatever information you throw at it. We took this mostly in aerospace, but in some other areas. In automotive, we did testing with a car company where we visited a dealership and intentionally broke 4 cars and asked their technicians to fix it. And it was a mix of technicians who had 12 years of experience and others who were 2 months out of college. Some used the case-based reasoning tool, some didn't. And what we found for the ones who didn't use the tool, the master technicians found the fault 4 times faster than the apprentices did. But when we switched over to using the tool with a new set of technicians, the experts didn't get any faster. They already knew everything that was in the tool. But the apprentices were able to solve the problem in the same time that the experts took. Basically, the system allowed those novice technicians to perform as if they had the same expertise and knowledge as someone who'd been in the industry for 12 years. So bringing that back to the cultural sector, what's a parallel here? At Magnify, what we're really excited and focused on right now is applying this technology for use in audience discoverability strategies. We think that we can take the knowledge of the best industry experts in marketing and audience, codify that into the CBR system, and then supplement it with historical knowledge of project performance that's coming out of the viewer-centric application. We can then merge those two into a repeatable system that allows a producer evaluating a new project to start defining their go-to-market strategy. Put in some basic facts about the project, start working through a guided interview that's going to ask, what are your constraints? What are your goals? What are your revenue numbers, eyeball numbers? Run the CBR to take a look at that plan and diagnose its weaknesses, just like we were able to diagnose the failures in the cars and the aircraft. In the same way that we were able to suggest tests and repairs in order to bring that equipment back into service, it'll make suggestions. But instead of saying check for a fluid leak, it'll say bump up your social media outreach efforts, particularly in the Hispanic community. I'm just looking at the clock and I've run out of time, so I'm going to cut off to leave room for questions. But this is something I'm really excited about, and I think the opportunities bode well for AI analytics in the creative and cultural space as a result. So thank you. Patrick, back to you.
Thanks very much, Mark, and also thanks again to Phil. So just again to actually encourage all of you to put in questions and comments into the chat. Please just type something just so that we know that you're alive. And also, if there was any, in amongst all of that content, any words or terms, phrases that didn't make sense to you, now would be the chance to pick us up on that and just put that word or phrase in the chat, and we'll attempt to define it. But to kick us off, I've got just a couple of questions around ethics. And I think, Mark, when you were introducing yourself, you mentioned that you'd be willing to talk about them. And I think there's something about buying watches or buying artwork, which perhaps isn't usually very revealing about me, the customer. Whereas if you think about what books you read, what films you watch, what plays you go to, potentially due to the subject matter of that, or due to perhaps who's involved or whatever, people might be able to conclude something about my identity group, my beliefs, my things which are very private, sexuality, all kinds of things, faith even. And so I just wonder, first of all, Mark, what you thought about the ethics that we need to be really, really careful of in setting up these AI systems, and particularly maybe around the kind of data that we use.
Yeah, so it's a huge topic in the industry right now, and there are a few people I follow who are working very actively with that, with centers for responsible AI and organizations like that. One of the big issues is really with data sets that appear to be sanitized when taken in isolation. But if you then get your hands on 2 or 3 or 4 of those data sets and you're able to start correlating them, you can statistically start deducing information about people that you couldn't get from any one of those data sets. And it's an area which, I think the universities have started doing a really good job of in the last couple of years as they train people in these areas, is to make them aware and really think about how do you sanitize that data to make sure that the sorts of personal information that you mentioned, Patrick, aren't leaking out and going into other areas. And I think it's absolutely very relevant to this space. If you could look at the full viewing history of everybody on Netflix or Amazon or wherever, there's all sorts of things that you can deduce from that. I can easily tell whether my wife or my son has been watching TV most recently based on what's being recommended by those systems. So those are good examples. Another one, I was doing some investigation into the medical industry recently, and they're really dealing with some challenges there. They're having a lot of success applying AI to medical analysis. But again, everything is data set driven, and the data sets that they have historically have focused on white Caucasian males because that's where society in North America used to put their time. That's really starting to change, but the historical data sets haven't caught up. And so what they're discovering as they look at this is there's some real equity issues where a data set that's predominantly focused on one segment of the population will of course cater to that segment. The AI itself is not biased, but its goal is to do the best job it can across the data set that it's given. And so if I give it a data set which is 1,000 middle-aged white men and 10 young people of color who are female, it's going to optimize itself to do 2% better on those thousands of middle-aged white men at the expense of performing much worse for that much smaller demographic. And that's something which, in healthcare definitely can have some ramifications that are quite serious and is drawing a lot of attention. So for anybody who's, got young kids at home thinking of going into a career like this, ethics in AI is a huge topic right now, and it's only going to get bigger over the next couple of years.
Yes, I remember going to an event a few years ago around innovation around data, and I asked everyone on my discussion group table if they'd done an ethics module in their computing or other maths degree or whatever. No one had, and I weirdly, I don't know why I ended up doing one, but I did. I remember it was the only thing I had to write essays for, and I found it very difficult. But the importance of it is essential. I think infamously, the British government on .gov.uk had some kind of automated face recognition within the passport application, and it didn't work with many people of colour, which is just a horrendous admission for something which is a public service. I was so shocked when I saw that. And we have a question from the floor. Sanitize. So what was the definition of sanitize? Is it removing personal data? Was it kind of removing things that were identifying individuals, or was it doing some other kind of cleaning?
Yeah, so in the sense that I used it, it absolutely is removing personal identifying information. So taking names and replacing them with generic identifiers, making sure that you stripped out social insurance numbers, ages. Ages can be important. So typically you would, rather than saying Mark's birthday is January 2nd in a year that I won't mention, we'll say Mark's age is in this range that I also won't mention with like a 5-year bracket. And of course you wouldn't say it's Mark's age. You'd say it's person number 1, 2, 3, 4 is in this age bracket.
Okay.
And that generally works really well for a single data set, but there are ways to defeat it once you start combining multiple ones.
I remember doing a government rollout of a service to have all childminders and childcare facilities in one single database, and of course with the safeguarding issues around children and looking after young children. And even if you had the first bit of the postcode, like a zip code, in some country areas, you could actually identify or have a pretty good idea of which house it was. And so we had a real challenge to do geolocation, but make it fuzzy. It was a real challenge. Phil, please talk to us about ethics.
Sure. I mean, how much time do we have? We could talk about this all day, really, but a couple examples kind of that I recently had read about kind of come to mind. The classic one that I'm sure most have already heard about is kind of criminal injustice and bias, especially in the U.S., right? In the U.S. criminal justice system, if I remember well, about 1/3 of the population in the U.S. actually has a criminal record. So, they're trying to develop systems to predict kind of what type of sentence should be handed out in the courts, and that's very dangerous because, you know, if there's an inherent bias that's already there in the justice system, you're only going to perpetuate that over time, and that has serious impacts to the people on the other side of it, right? Because if you think at today, the gig economy, you know, you want to be an Uber driver or, you know, other types of jobs, there's always a background check, a criminal background check. And so if you do have a criminal record, that automatically excludes you from you know, being an Uber driver, for example. So it only accentuates the divide between different classes. So it's definitely something to be mindful of, and, you know, to be aware of, you know, garbage in, garbage out with data. If you feed bad data into a model, you're going to have bad predictions. And so that's a example where, you know, the consequences are just devastating for the person on the other side. Another example, a little bit lighter, but still pretty bad, that I was reading about Instagram, how basically there's algorithmic bias with Instagram, because essentially the people that get the biggest hits, the biggest views, are the ones who show more skin. So it's actually incentivizing users to show more skin on their posts, right, to get more hits. So I think it's just a terrible thing. It's teaching the wrong values to teenagers, for example, and that's something else that, you know, needs to be looked at more closely, and we need to find ways to eliminate that kind of bias in our algorithms out there, because again, you're basically setting the wrong values up to kids that are pretty impressionable. And with the U.S. Criminal justice system example, I mean, that has serious consequences on people's livelihoods, and it just, again, it accelerates the divide between, you know, lower class, middle class, and upper class people. So, you know, any biases will just get perpetuated. We have to really be careful with that.
So I did actually rewatch Minority Report in January. So I think we know what happens when it goes wrong. There was another question from the floor, which is a point of clarification as well, just to explain that idea about Bayesian, and because I remember from my maths that it's about logic. That it's about kind of percentages and probability and those kinds of things. But maybe I'm being unfair, but Phil, as you were speaking, kind of, what's your off-the-cuff definition of Bayesian?
So I'm not a statistician, but it's from my understanding, it's basically around probabilities. It's a theory basically used to update the probability for a hypothesis coming true. I guess that's kind of the easiest way I can explain it. But again, I'm not a statistician, so don't quote me on that.
I did maths as my degree, and statistics was the thing I didn't take. Mark, maybe it's worth kind of explaining also how the probabilistic nature of the world then gets turned into the kind of tech bit.
Sure. Yeah, so at its core, the Bayesian theorem is all about probabilities. And if I know the probability of something happening in general, and I also know the probability of it happening given something else, now when it does happen, I can correlate back, and that's a terrible explanation. Let me try to apply it to something concrete that's very current for us all. COVID testing. We all know when we go to get a COVID swab that it's likely going to give us the right answer, but there's a small percentage chance that it's going to tell us that we're COVID positive when we're really not. And there's also a small chance that it's going to tell us that we are not positive when really we are. And I may have just said the same thing twice. I mean, just say the flip. If we know what the probability going in of that test being accurate is, and we know what the percentage of the population as a whole that has COVID is, now when my test comes back positive, the Bayesian formula allows me to correlate those two numbers and give a third number, which is how convinced we actually are that I have COVID. So let's say I'm somewhere in rural Canada where no one with COVID has ever gone, and the population that has COVID is very low. It's 0.001%. When my COVID test comes back positive, the fact that it's so low prevalence in that area is going to lead us to believe that my positive test is almost certainly a false alarm. But if you look at where I actually live in Mississauga, Ontario, COVID capital of Canada, where our prevalence is really high, when that test comes back and says that I'm positive, everybody's going to look at it and go, dude, for sure you're positive. The chance that this is a false positive is almost zero. And that's Bayesian at work, is it's looking at those other factors. And where it feeds into AI is you can chain Bayesian together. It gets very complicated very quickly. I spent a few years working with it, and I wouldn't claim to understand it beyond more than 1 or 2 steps, but people who are much better at math have built out whole systems that hide that complexity and allow you to chain things together and basically just say how likely they are to happen in isolation, and then fill in the details on what you actually saw happen. And it goes off and churns the math and statistics and comes back with the recommendation. So it's good when you have experts who understand the statistics and you want to draw conclusions from that. It really starts relying on the human knowledge in order to overcome the fact that you don't have low-level discrete knowledge, or sorry, low-level discrete data, and the data that you have is at a high statistical level.
So folding back round to the ethics and justice side, it's a really interesting question from Sean in the chat there. It's interesting. There's a kind of research way of looking at this. So obviously in academic research, there is often an ethics consideration. There's a kind of ethics review, that's kind of part of the higher education world. It's interesting how in some senses some evaluation and some research in arts, culture and heritage may be in partnership with HEIs or maybe trying to be at an academic level. Definitely in the UK, we have a British standard now. I can put links in the chat about responsible innovation. So then that's moving into more applied research, more practical things that can be in businesses, can be in non-profits, can be solving creative and societal and business problems, not just in a sense developing academic knowledge. And there's definitely, excuse my ignorance of the Canada situation. It's one of the reasons why we're collaborating with Synapse, but that idea of inclusive innovation and that inclusion being, inclusion in the people doing it, inclusion in the people that you're researching with, inclusion in the people building the technology, inclusion in the data that they're using these examples. And in a sense, it's not good enough to be kind of neutral. A neutral stance isn't good enough because one has to very actively think about how different groups are represented in the use case, perhaps, and in the data. And it may well be that your stance isn't a totally neutral stance, because it really depends on exactly what you're trying to achieve with whom, for whom. Certainly in the UK, there's lots of things around those who are less socioeconomically advantaged being much less engaged in culture, and therefore being a priority on them. And so then one would have to be thinking about, if it was an AI project, and making sure that the data was properly representative of them, and indeed that it didn't embed assumptions about that cohort of people that came from people outside it. So it's a very active thing. Will funders pay for that? I don't know the answer. It may be that there has to be some car crashes, as it were, some bad outcomes before they realize the need to. I really hope that that isn't the case. And I think that with COVID, the accelerating the adoption of digital across all sectors, but especially perhaps arts, culture, heritage, these things, not just of discrimination, but of equity, even just at the basic of equity of access to different cohorts, has come forward more to policymakers and funders' minds. So I don't know. I think everything's negotiable, and it may well be that one has to explicitly put why you're doing that and explain it again explicitly, and explain the benefits of that to the diversity and inclusion of the people who will be involved in making and enjoying culture, and that it becomes a much higher up the agenda, as high potentially as the creative idea that you're putting forward. That's one. Yes, data is never neutral. In a way, it's that idea of I know, trying to explain to some of my friends earlier in my career who didn't work in TV and film, kind of how there is no neutral stance of a director. There is always a human being intermediating between what was being filmed and what you're watching. And that person, whether you think that there's a director or whether you think it's very neutral, there's always a stance, even if they're not aware, but quite often they are, of course. And so the same is with data, where you choose to get it from, where you choose not to, and indeed where you kind of implicitly do and don't get it from, and what data you include is really essential. I'm aware that I've been asking you questions, and I think from our previous conversations that you might have had some questions to ask of each other. So Phil, you've got Mark now. You've got him cornered. You can ask him anything you want.
Oh, I hadn't really given it some thought. Where do you see things going, say in your industry, in your line of work with Magnified Digital, as far as AI goes? How's that going to play a role in kind of your day-to-day?
We see it playing a huge role in the future. Right now with viewer-centric, we're doing some really good work in terms of collecting objective evidence of the success rate of a project by looking at viewership numbers coming in from broadcasters and streaming services, social media likes, page views, Twitter, hashtag references, pulling that all together and providing some really good objective evidence. We're still building out that data set to get it to the point where it's going to be big enough to actually drive some machine learning from. But both of the projects that I talked about, I think, have direct parallels, and I alluded to them in the presentation. We can take that data that we're collecting in viewer-centric, use it to train a predictive model, and then supplement that with the expertise of people in the agency, bringing in the case-based reasoning and really ending up with a hybrid system, which is saying, okay, this is what you want to pitch. This is how it's probably going to perform. And these are some tweaks that you can make to it to improve its performance, and really take them through that step-by-step process that, going back to the automotive example, lets someone who maybe is early in their career benefit from the performance and learnings and school of hard knocks of those who've come before, in order to make their project the best that it possibly can be. So it's really what interests me and intrigues me, and the reason that I came to this industry.
Oh, thank you. I'm aware of time. I'll just be very naughty and just sneak in the reverse of Mark asking Phil, and then we'll say goodbye and make sure that people out the door by midday your time and 5 o'clock UK time. So Mark, you get to ask Phil one question, the question you've always wanted to ask him.
So I used to be a watch aficionado, so I really want to ask about the watches, but I'll try and keep it on topic. and really talk about, the idea of biased data sets. As you were looking at that watch project, I know these days the luxury watch market is largely centered around Asia. And I believe that what they are looking for in their products is not necessarily the same as you would see in Russia or Europe or North or South America. How did you balance that out so that you weren't just swamping the other markets with data from that one market?
Well, great question. Luckily, the watch manufacturers, so they don't really export. They only deal within the country. So that wasn't really a big issue coming up. Having said that, though, sales are very different from one region of that country to the next. It's in Brazil, in fact. So it's public knowledge. You can Google this on our website. One of our customers. Yes, Seculus, that's the name of the company. But essentially, yeah, I mean, they do very little export, so it's not a huge consideration, but they do work with Asia. That's where they get their parts, but they have to manufacture them within Brazil, because Brazil has just so many laws and regulations. But to your question, yeah, I mean, it is something we're going to look at. We haven't looked at it yet, the differences between regions, but really the biggest driver is in fact the big department stores. They're their biggest customers. They're prevalent in different regions. So depending on who their customers are, these wholesalers, they definitely do have different preferences. I'll end on this, a funny anecdote. I was talking to my customer last week about that, and he was talking to me about how there's a lot of psychology that comes into play when trying to predict demand, especially with these department stores. When they see that there's very little inventory of a certain product, they'll want to buy as much as possible. There's this fear of missing out. Whereas if you have this brand new watch that's going to sell really well and you have plenty of inventory, they'll just take a little bit. So there's no sense of urgency. So there's a lot of psychology that kind of comes into play. So I'll have to think about how maybe that could potentially be incorporated into the model and kind of not have that bias. Another kind of funny thing around bias is with the launch date. So one of the issues I was seeing with the data was that you would have sales 2 years before an official launch date. And I couldn't scratch my head around it. Why is that happening? And the reason for it is essentially they would relaunch the watch 2 years later. And again, due to psychology, salespeople would only sell brand new watches when they come out. So they would kind of forget these older watches. So they would have to kind of almost play a trick on their salespeople and relaunch the watch to get them to start selling it again. So there is some psychology that's kind of involved. And it's only by working closely with customers that you uncover these business insights and then have to figure out ways to account for that in the model that you're building.
Certainly on cultural data, my final point of the day, other than saying thank you to everybody, is in the UK, I know there's a big focus on the data of non-domestic audiences, and that's the connection I'll make. And so it remains for me to say thank you very much to all of the colleagues at Synapse who've made this happen, to our translators for today, to you, Mark and Phil, for giving us such wonderful examples, and for all of the participants. We thank you very much indeed. We hope that that gives you food for thought. Please do continue to be involved in the conference. If you liked it, tweet about it. If you didn't, tell your enemies. And we'll see you soon. Thanks very much indeed.
Thank you, Patrick, and for keeping things moving, and thanks to everybody who attended.
Yes, thank you. Thanks for the questions and all of the comments in the chat as well. That really makes a difference, because we can see that there's someone else in the room.
Thanks, thanks, Mark.
I'm going to finish up. We're slightly beyond our official time, but we're just definitely in time for everyone to go to the next session. So I'll love you and leave you, and I'll actually finish the meeting now. So thanks very much indeed. See you soon.
Thanks.